Hey, what's going on, guys? Yesterday I got an email entitled "Need Help" from Amar Ahmed. So, Amar Ahmed, if you're watching this video, this is dedicated especially for you. So, here in the email itself, Amar asks how to scrape the data from the table, and he provides the screenshot of the exact table to scrape data from, and also the link where this table is actually available. So let's go to the link itself, and here we see the table, right? And also we see, I can already say that we see much more tables here as well. So I guess the problem is to pick up the table itself. Well, actually, let's try to see if we can kind of do something here. So first I would like to inspect the elements here to make sure that it is a table. Yeah, so this is the table tag. And you know, like when one starts developing the logic of data extraction within the given page, you know, like the pretty common way to go is first try to extract the parent elements and then actually go in for extracting the child elements. So in this case, we need to extract the data from the table. So the very first thing to consider is actually to find the appropriate table itself. So here it is basically. But you know, like also we have the table over here, and we have many tables, another one over here, and so on. So we need to find some sort of a unique something unique to the particular table over here. And what comes to my mind at the first glance is actually the border equals to 1. So we could have used probably this attribute to distinguish between these tables. But I guess if we just scroll down slightly lower, then this table would also have, I guess, border equals to 1, but also cell space, cell padding 2, cell spacing 0. And what about here? So okay, cell padding 1 is this. Okay, just again, I just need I'm just trying to find. Okay, so yes, cell padding 2, cell spacing 0, so exactly the same. Well, but nevertheless, this table seems to be the very first one. So as far as the only page provided here, so I can't see any pagination. I guess just matching the very first element with the given parameters would be basically just fine. So we need just to distinguish between these tables over here. So the first, the second, and this is the third one. We could have actually just find all the tables and then use simply use indexing to match the particular one. So well, probably I think I can cover both cases. So well, let's actually start writing some code. So I'll create a folder here. So table data extraction. Okay, and let's create a file in here. So empty document, and I say table data.py. And as far as we have the only page to crawl here, I'll probably go for using requests and beautiful soup rather than Scrapy, because it's kind of more easy and beginners friendly, and also I can't see any reason for using Scrapy here. But still, I will probably provide some Scrapy selectors as well. Maybe I'll just create another file here. So okay, let's basically call this one let's call this one BS, which would stand for beautiful soup, and we'll also create another one, table data Scrapy, that would be using the Scrapy framework. So in any case, first we need to import our packages. So I say import requests, and from BS4 beautiful soup. And probably now we need to make HTTP request to the given URL. So I'm creating the response object that would be equal requests.get, and here I provide the link itself, so just copy, grabbing the link. I hope no headers are needed here, so I just hope it would work without specifying any headers or cookies or things like that. But nevertheless, we of course we need to check that out. So let's just print the response, and I hope to see the response code as the response status code to hundreds. Also, I need to invoke my terminal in the current working directory, and by typing python 3 table data bs.py, I invoke my script here. Okay. Okay, so he has the response to 100, which is okay. So the response should have been just kind of fine at the moment. So now we can actually start parsing our response. I say parse response, and create the content variable that would be equal beautiful soup, and here we're using response.text as the argument to parse, the first argument, and let's specify LXML parser. I'm used to use this one, LXML. You can use HTML.parser as well if you don't have this installed or don't want to install this. Don't forget to pip install requests and BS4 and LXML if you use it as well. But as far as this is different on different operating system, you just need to be aware of how to use pip actually to install the packages. So requests, beautiful soup, and LXML should be installed to make this script kind of work. And now let's try to extract the tables. So if we just let's try to extract the tables basically. So say content dot find all, and let's start looking for the tables. So if we have a look at all the tables, it would return the selector, I believe. So let me just try to print tables. Print tables, just to make sure regarding the data type being returned here. Okay, now he already returns the entire table set. Okay, still this should be a list, right? Yeah, this is the list. So let's see the length of the table, so we'll understand how many tables that are available actually. Okay, so there are exactly 10 tables on this page, but obviously we don't really need those. So let's define here extraction method 1, and here we'll say table equals, so the very the most, I just mentioned this, so the most dumb way of doing things, but still it's pretty workable, I guess. So we just need to calculate the number of tables in the source code. So let's just go for them. So we have table 1, so index of 0, index of 1, and index of 2, index of 3, the first page. So let's try to print tables and the index of 3, and let's try to print the table. Save and run. Okay, so no, I didn't. So word banks, word list, so probably it's not, I missed something. So where is the word banks? Is this the next one already? Okay, let's just try one back and forth. Table cell space in bg color. third, fourth. I can see where exactly. Okay, so let's. What is this actually? Holidays, adjectives. Well, it seems like it's our table, or yeah, adjectives, adverbs, alliteration. Yeah, here it is. Amphibians, anagrams, animals. Yeah, so this is it. So yeah, it's actually index of 4, so the 5th table on the page. So this is the first way. Okay, another way might be, so well, let's call this table indexing, table index. Just don't want to call variable like this, but okay, let's table method 1. Okay, so method 1 is called indexing, right? Okay, and now let's go for another method. So extraction, it's not actually extraction, it's kind of table extraction. So table extraction method and 2, and let's first define this and then table and then call it accordingly. So method 2. Okay, so now we can try to find a table within tables. Actually, I'm just wondering, can I use can I say, hold on a sec, tables dot find table. So I hope this should have find the very first table available. So I'm not sure though, but let's check this out. Didn't work with Beautiful Soup for quite a bit of time because of switching to Python Scrapy completely, so don't remember everything by heart basically. Okay, single item. Okay, so yeah, we can't do this, so let's actually try. Okay, just forget this. So it's already tables is already a list. It's not a selector. But yeah, we can use the selectors recursively. But yeah, okay. So let's try. Okay, so probably this is more logically to be put over here. So extracting all the tables and then just trying to index one of those. Okay, so here we'll try to specify okay, find all still, but here we'll specify some unique attributes. So let's go here and see what we got basically. So we have well, the width is probably always equals to 100%, but this one is more or less unique. So border equals to 1, cell padding equals to 2, so we just need to grab this entire stuff. So okay, let's try to say border equals to 1, and well, we can actually provide a dictionary this way, I guess. Hope no indentation errors or something. To arise, there is cell padding copy cell padding equals to 2, and what else, cell spacing equals to 0. Okay, so and yeah, now well, first let's actually try if this extracts at least something. Okay, it seems like, and I guess that now the very first element should be what we need actually. Not sure, but it seems like the table with the specific parameters is the very first one in the table. So I guess this should work. yeah, exactly. So now we did extract this again. So as far as this is the very first element, we can get rid of find all, and in this case we don't need indexing at all, so we can just simply find the very first element by default and get exactly the same table we're looking for. So let's call this method specifying. Oh my god, I forgot how the specifying word is typed. Sorry, just need to Google Translate this quickly. Copy. I'm sorry guys, just to avoid any grammar mistakes. I really don't like to do those. So specifying, yeah, specifying. I did I did actually spell it correctly, it seems like. Okay, great. So specifying unique unique attributes, tables unique attributes, like this. I don't know, it doesn't seem to be it doesn't seem well, attributes, okay, and yeah, and picking up the very first one of the list. So that's more precise definition. Okay, so I don't know, like, I can't really see any other unique unique features for this table, because like it's really, it seems like to be the same basically. Maybe just the, I don't know, maybe, I don't know, font size +1. Maybe some table data tags have some sort of a unique selectors as well, like the font size. But like, as far as this is the only page, I can't see any reason for doing that basically. So regardless of what kind of method we use in here, so let's actually go for extracting our actual data. So now we need to take all of these guys. So well, at least to provide the selectors, as far as this was the exact request in the email, so just stuck ours getting a selector for it. So, well, I guess this already answers the question, but nevertheless, let me just quickly provide so table data selector. So I'll be using, I don't know, doesn't matter if we use the table method one variable or this one, they are literally the same, but I just will use this one. So I'm not sure, can I actually recursively find so okay, let's try to create a rows variable that would be equal table method 2 dot find all, and we're looking for all the tr tags, right? Save, and let's try to print our rows now. I'm not sure if this works actually. Yeah, it seems like. So we did extract successfully all the rows, and now we need to extract this. Okay, probably I'm not sure if we need just the list of these words, and we don't need to keep the structure of the table. We could have just be looking for the A tags, the links, and the H, the both, like H references and the titles themselves. I'm not sure if it's really needed to to keep this kind of structure of the table. So, well, as far as I'm not sure, let me just try to keep that actually, and let me see how exactly we're supposed to be doing this. So within the table row tags here. Okay, so table row. Okay, and so it seems like okay, so it seems like it's the only row, so all this stuff is the only row, so it doesn't have. I thought it was like kind of row 1, row 2, row 3, etc., but it seems like it's the only row. So we need to find all the TD tags within this table row. Okay, so let's try. So yeah, this. So so in order to find columns, right? Let's call this calls. So we need to loop over the rows, so I'll use the list comprehension technique here, I guess, right? So column for column in rows, and for each column, well, actually no, not like this, so this is actually a row. So for each row, and hold on a sec, but we have the only row here, right? So let me just quickly check that out as well. So the length of the length of rows, so it should be equal to 1, I guess. Yeah, 1 row. So we don't even need to use this find all, but instead we can just make it like so, right? And if we now print our rows, I guess, yeah, we'll have exactly the same. Great. So now we need to extract the columns. So columns would be equal. Well, it's not rows even. It's the only row actually. So we simply say row dot, and this time already find all, because we're looking for all the table data tags, and we'll get exactly 4 in return. And if we just now print our calls, I guess we'll have, yeah, only the table data tags, and the length of this would be 4. Yeah, so 4 columns exactly, just like on the web page itself. 4, right? And okay, what else? So now we need to loop over. Okay, just hold on a sec. I'm just thinking how exactly to describe what I'm supposed to do here. So let me just try to explain this visually. So let's consider the Python list, right? And here we have the list 1, the list 2, list 3, and list 4. And every list would contain all the links. I know, like, this probably doesn't make sense at all in regards to this particular case, but still, if you're dealing with a real table, it might have made some sense. So I'm just thinking how exactly, what would be the best way of doing things. So as far as okay, can we just so, well, maybe the way I go here would be like, let's assign the value to columns again, and here using the list comprehension, saying call for call in calls, and for every call. Okay, let's try the very. Okay, let's try to find the only one A tag. Just want to have a look at this data structure here. Okay, and yeah, please print columns. Okay. So 1. Okay, 2. Right, now this is it. 3, 4. And if we're just trying to find all here, then we'll have respectively, okay, yeah, the list of lists just as mentioned here. So just to print this, we can say this would be the table-like structure I've been mentioning, basically. So if you would like to, oh my god, why is this so? Oh, it's because, yeah. Let's limit to the only element. So okay. Yeah, unfortunately it doesn't load to, well, it does work, but the data is too has the too long width, so I just can't really print this the way to show this kind of stuff, like list and so on. So this structure is what is actually available now at the moment. Okay, but let's better actually try to so we need to find all links, and for every link we actually need to extract the particular we need to, okay, let me just, it's better, or I just don't want to, I just want to keep the code as simple as possible, basically. So okay, maybe let's call this one links actually, and now let's call this one data. I could have made this all this stuff within the single within the single line, but I just want to keep the code as simple as possible for clarity and for educational purposes as well. Okay, so now we have let's actually try to print link for link in links, and print our data. Okay, and we need to extract both the H reference and the title itself. So from here, here we actually need to create a dictionary. So we'll have two values. The first one would be the H reference, and this would be a link, and the H reference like this. And also we need, well, let's take the title first actually. So title, and let's consider link dot text if memory serves me correctly. So okay, let's try to print this stuff again. What? Oh, okay, so I'm just wondering why well, this is slightly strange, so just what's the type of link? I'm wondering. Type. Result set. Why is this the result set? I'm really wondering. And what's the type of links? Is this a result set as well? It's a list. Oh, I'm sorry. Probably if I just say link dot, I have no idea why. Okay, let's try to print the data, the very first element. So I just want to have a look at the single link. Why it's supposed to be the result set? Oh my god, it's really the result set. But why this happens? Okay. So column is the table data. So something has gone wrong basically. Okay, let's have a look at the links again, it seems like, okay, yard. Something wrong with something is definitely wrong here. Yeah, you know, like now at least I understand that it's really not. It seems like very trivial task, but these tiny little details makes the one to think. Okay, it's probably because it's the list of lists, but why this happens? Why on earth this happens? I have no idea. So links. Okay, how many? So this should be 4, I guess. The len of links. Yeah. Okay. Okay, so the links 0 in this case should be the length of all 43, which all the links, so 43 links per every column, right? Okay, so for every link. Okay. Okay, guys. It seems like I did manage to visualize this in my head. So links are the columns. So there are 4 of them, and link is not a link actually. So let's call this one a link set, and this call this link set as well, and this would be links respectively. So let's have a look again at data. So the length of data now should be 4 because we have the 4 link sets, right? Okay, and data 0, data 1, data 3 respectively. This would be link already links within every link set, so we're within every column basically. Okay, so now for every link we need to extract this dictionary, so I'll try to make use of another list comprehension here. So I say link for link in link. So I hope this should work at the moment. No errors, great. And here actually I guess we can already try to extract both text and H reference from every single link. So like this. And let's try to print our data again. Yeah, great. So now we have this basically. So yeah, let's try to just to verify this visually. I just want to import JSON and save. Let's actually try to print JSON dumps. Well, I hope this is JSON serializable at least. Okay, data and indentation equals to 2 spaces. So just want to have a look at this data in the JSON-like format. So yeah. Okay, so this is the very last column. So winter yard weights and measures. Let's have a look. Yeah, winter weights and measures, winter yard. So with the very last, and okay, and then we are going for this column. So said rooms, rock and minerals. Okay, said rooms, rock and minerals. Great. And all the words here. So we did extract both the title and the H reference. So we could have also append some. I guess we could have also append the base URL to the H reference. So let me just try to open this in a new tab. So word list. Okay, word list, and the word itself. Word list. Okay, so let's try to append this kind of stuff here. So let's call this base URL and title link reference. So here we say base URL plus link hrefs. Okay, let's try this one more time. Okay, now we have kind of working. Okay, it's not yet the end. Get rid of this stuff. Okay, now this links should be okay, I guess. So let me just try to copy and paste. Well, as far as I didn't have any request, yeah, it works great. As far as I didn't have any requests regarding storing the data to whatever output, using whatever output format, I won't be doing this. But now I just want to crawl through all the elements within the data and then through all the links. So to print them not in this like JSON format manner, but just to extract all the available title and the href from the page. So let me try to do that as well. So loop over columns, right? Or otherwise another name for this, like link sets. And here we say for, let's call this column in data, or okay, let's call this better, link set, for link set in data, right? Oh my god, where's the A? Data, and now the link set is the list itself, so we can say for link in link set well, it's not only the link actually, for well, okay, forget that. So here we can simply say print link and link title, so we'll see all the titles available, I guess, at least. Okay, so seems like all the titles available, great. And another thing we could consider here is actually to also print link href. So okay, link href, great. And now if for any reason sorry, I forgot what's the name of the guy, Amar Ahmed. So Amar, if for some reason you would also prefer or like or need or whatever to crawl through these links, so I call this make recursive HTTP get request to each link, to each URL, maybe like this. So here you can simply say let's call this recursive response, and this would be equal to requests.get and actually link href like this. So next URL like this, this would be equal to link href, and here we'll specify the next URL. Yeah, it's not really that easy. So also I just want to print this recursive response. Well, let's just call this recursive like this. Recursive. Oh my god, did I spell this correctly? Okay, let's find another way, another name. So link link response. Like that's called link response. Let's keep this link response. Okay. So now I hope to see like a response to 100 for every single link we're having here. So here you can parse. I just say you can parse recursive response here, and yeah, just print this one. So like again, we need to use the beautiful soup to, so okay, link content would be equal to, again, beautiful soup, and this time link response, and again the XML parser, and yeah, so we can also print the let's start with, actually, well, let's first try to print the bare responses, right? And okay, response has no length. What? Oh, sorry. Dot text, of course. So yeah. Okay, so we're now making recursive responses to every link if needed, of course, and also I just comment this out. So now let me just try to print link content, and we'll see the beautiful subselector, I guess, right? Yeah. Oh, it even just gives the entire HTML. So this is kind of it. And now you can say like link content, find all or find or whatever, and just search within the links within the recursive HTML responses. So, well, I guess this is it regarding request and beautiful soup way of doing things. So yeah, Emmer, you know, like at first I thought like it's trivial to do this, but after spending, I have no idea how much time I spent already, but yeah, now I realize that it's not really that kind of easy, basically. So let me just yeah, prettify my code a little bit. So from now on, yeah, let's just hope no indentations error here is no, yeah, it works. So I'll leave this code as is, and now guys, for those of you who is interested in how to do absolutely the same using Scrapy selectors, I'll try to go very quickly over the process of creation exactly the same data extraction logic with the Scrapy. So I really hope this would be faster, because I already did find kind of all the selectors, but in Scrapy this is done even easier, I guess. Well, let me just show you this. So let's call this table data Scrapy.by, and the same like packages, and here we need to import Scrapy from Scrapy dot crawler, import crawler process, and let's provide the main driver, simply saying if I will go very brief, if name equals to main run scraper, I create the process instance that would be equal to crawler process. Basically I'm creating the crawler process instance here, so process dot crawl, and we need to provide the name for the class. We didn't yet create this, so let's scraper class okay, table data, let's call this just table data. It will inherit from the Scrapy spider, and scraper name will be equal to data, doesn't matter. Okay, and now we can also use this one as the argument, you know, for the crawl method, and finally process dot start, save, and now let's try to run table data scrapy.py. So I hope it works. Okay, for some reason it doesn't. Python 3 table data scrapy.py. Okay, crawler process. I forgot to call to call the constructor. Sorry. Okay, now this should work. Come on. Crawler process. Save. Yeah. A little typo here, which is not really seen at the moment. Okay, so now the scraper works. So start URLs, which is the fastest way to provide links to crawl in Scrapy. So it's called start URLs, which is the part of the Scrapy spider base class we're inheriting from. So start URLs would be equal to, and we provide the only element here, which would be this link, word list, copy, and paste, save, and parse response. I guess by default it's this method is called parse. Yeah, takes the self instance and the response object as the argument. So let's try to print. Okay, just to make sure the callback function actually did fire, and yeah. So let me just check this out. Okay, so callback function did first, so we can now, from now on, we can work with our response object. So in Scrapy, this is gonna be slightly a little bit different, and but the only thing that would be the same, I guess, it's well, how to extract the table. So first say extract table. And table would be equal response.css. We're looking for the table tag and the argument and the attribute of order. Equals to 1. Okay. I guess this shouldn't be enough, and just try to get the only element, and let's try to print our table. I want to see the HTML response. I guess that there would be some HTML. Nope. Got number 1. What a man. What is this? Okay. Okay, it seems like it doesn't like this one, so let me try to enclose this with the double quotes. Okay, now he did extract the exact table we need, right? Great. So, within this guy, we actually want to find all the links. So it's Scrapy. This is more can be done simpler and faster. I believe so. Links would be equal to table.css, and we're looking for all the A tags, right? I'm just thinking how it's better to be done here. So well, let's call this one links URLs, and this would be attribute hrefs and get all, I guess. So let's try to print the link URLs. Okay. Doesn't like something. Okay. String has no attribute CSS. Oh. Hold on. It doesn't need. Yeah. Now, unfortunately, he gets even more. Okay, but so let's try to specify what exactly. Okay, maybe we can go even easier. So yeah, I'm not sure if I remember the syntax correctly, but so word list. So every has the word list. So I guess we don't even need this table. Let me just get rid of that for a while and simply trying to ask response CSS, and we're looking for a tags which has the href where href contains word list keyword. So I'm not sure this is gonna work, but let me just try this. It's intriguing, right? Okay. Word list idea matrix. This is not. This is different. Okay. No, it's not. Idea matrix. Writable category. Word list. Okay, this SHTML. What about this guys? So it's okay. I believe he takes this guys as well. So alphabet. Okay. But idiometrics. Oh, maybe that's because it's asynchronous, or I have no idea. Like. Let's have a look at the page source. Word list. Yeah, it's far more, it seems. Okay, so we need only this word lists. Okay, this is SHTML. This also. So we need to find something unique. Okay, hold on a sec. This target top, is this unique? Is this unique? Okay, let me try. Nope. Okay guys, so from I just spent some time to research, and like I can see the way how to extract this directly, so I'll use some sort of a trick here. So I just got rid from the links URL selector, and let's try to print our table again, and actually let's get the very first one, right? So let's just okay. Okay, and I just wanna print the type of table. So I hope this is a string basically. If not, well, let's check that out. So yeah, this is string. So now we'll go the following way. So I simply say from Scrapy dot selector import selector, and here as far as we need to select not from from the entire content, but only from this one. We can go the following way. So basically we can say like selector and text would be equal to what we've just extracted from the table. So now let's try to print the type of table again, and now this should be a selector, I guess. Yeah, Scrapy selector. Okay, and now if we're just trying to say CSS, and let's try to find all the links. Well, I guess now let's say attribute reference get all. So I guess now this should give only those we're interested in. Yeah, so yard, winter, measurements. So let's have a look. Sorry, this is the Scrapy docs I've been referencing, and okay, oh, got a new email. Okay, so yeah, yard, winter, weights and measurements, right? Measurements, well, hold on a sec. Yard, winter, weather, measurements. Why this? Weight, okay, weather, and where is the weight and measures? Oh my god, let's try. Okay, just want to print this slightly a bit. So here I can say links equals to this stuff, and let's try for link in links print link. So just to have every next link been printed from the new line, or okay, yeah, not that trivial really. Measurement. Oh, that's because yeah, it's the link. It's not the title. And if we just try to see here that our titles, so just try to extract the text node. Okay. Yeah. So yeah, now this is just pretty nice. So yeah, now let's do literally the same we've done here. So so this would be actually titles, and links would be the same, but we're looking for attribute hrefs, and now let's look for index in range from 0 to the length of titles, and okay, let's call this or else. Okay, so also let's create our links as a list. So here I say extract links, unique links, list, save. Okay, and loop over titles and links, and let's just try to print like titles indexed by the index. I hope to see the same titles. Okay, and now we can say actually links dot append, and here use the dictionary. Well, it's not exactly the same as we did before, because all the links are not distinguished by the columns, but just we were picking up the entire set, but well, slightly different, but the gist essence is literally the same. So we have the title that would be equal to basically titles indexed by the index, and URL would be actually URLs indexed by the index, and here let's import JSON as well, import JSON. So now we can simply pre-print this link. So I say JSON dumps and links indentation equals to 2 spaces. So let's have a look. Okay, yeah, great. So the title and the URL, and now we can actually try to loop. Well, actually we don't need to provide another loop. Well, we can just, so if we just want to crawl recursively over this step, we can simply say response, say follow links recursively, and I say response dot follow, and this time we don't need to formulate the link using like the base URL plus whatever we got over here, because Scrapy does support the response dot follow standard method to crawl the links actually recursively, like that. So also need to yield this, and now the URL would be equal to URLs index, like this. Okay, let's call this like in previous, so next URL be equal to URLs index, next URL, and specify another callback function. So callback would be equal self parse. Let's call this parse link basically. So this one, this method should be fired on success. So parse link and def parse link. Again, it takes the self instance as the first argument, followed by the response object, and we just can simply print recursive link response, just to make sure it works, and let's bring the response itself. Let's try to break after the very first one, so, and then if it works, just get rid of that break statement. Okay, so recursive link response, and here we have like the URL being created dynamically itself, which is great, obviously. So we can get rid of this break statement, and let's try to print the response.tag. So from now on we can use again like response.css to extract all the data out of there. So now we'll see the HTMLs from every link being crawled recursively. Well, finally this is it. Okay guys, so it turned out that this quite pretty trivial at a glance thing turned out to be not that trivial, and I guess I hope that some interesting techniques has been covered in this video in particular, like using this custom selector to work with a particular separate element in Scrapy and in Beautiful Soup. It's also a bit different way of doing things, but nevertheless both work, both do literally the same, and actually it's you to choose which one in particular to consider in your project. So Amar Ahmed, did I Yes, Amr Ahmed. If you're still watching this video, thanks for watching, man. I hope this kind of content helps you, and thank you for the kind words you told me in the email. So for all the other guys, I just want to say like thanks for watching, and until next time, and take care.